All right, so we're going to break it down into two different parts. So indefinite integral, that's just basically finding an antiderivative. There's no bounds, and then we'll do definite integrals in the next video. All right, so our strategy, when we look at this problem, all right, there's one way you could do this that doesn't need substitution. You could take this whole thing and raise to the fourth power. I've been multiplying some expression like this to the fourth power is going to end up taking forever. All right, so we don't want to do that. But if you ever forgot substitution, you could do that and just spend a lot of time doing one problem. But we're looking for our g of x, which is one function inside of another. And you can see here with the parentheses, the first kind of guess would be to make u. Again, we're calling it u substitution. So u is the thing that is inside of another function. That's going to be 3x squared plus 4. We can't just put in u because then we have u's and x's together. So now we have to figure out how to get rid of the dx and make it a du. So what we're going to do is take our equation here and take the derivative of both sides. All right, so if we take the derivative of u, just like implicit differentiation, you get du. Derivative of 3x squared is 6x. And again, you take the derivative of something with an x, you get a dx. And the derivative of 4 is 0, so that part goes away. So if we make u equal to 3x squared plus 4, then du, the derivative of u, is equal to 6x dx. And here you have a couple different options. So in this one, because I think it's more obvious that you can see a 6x dx, which is exactly the right-hand side here. That's going to turn into du. You have a 3x squared plus 4 and a 3x squared plus 4, so that's just going to turn into u. So this problem is going to turn into the integral of u to the fourth, and then 6x dx turns into du. So you can see it simplifies the problem a lot. We have all these different x's and exponents. It simplifies it just into something raised to the fourth power. And now we can do the reverse power rule. So we add 1 to the exponent and divide by the new exponent. Then we have plus c. And if this was the whole problem, you'd be done. But we have to go back and remember that our original variable was x. So our final answer is we replace the u, again, with 3x squared plus 4. That's raised to the fifth divided by 5 plus c. And that's the basic idea. You can double check if you were to take the derivative of this function at the bottom, you'd get back to the thing that we had at the beginning. But this is the basic idea of substitution, finding one thing that's inside of another function, and you basically replace it in there so that you can make a simpler thing to integrate. And at the end, you just have to undo that substitution. So now we have square roots and things. Again, this one, there might be other ways to do it without substitution. Actually, I don't think there is with this one. You might be able to make it work. But again, for now, we're going to have this new tool that's really useful as substitution. So we're going to use it. We want to find our u, which is the g of x, which is inside of another function. Well, again, the only thing here that's inside of something else, we have this x squared minus 5 that is inside of the square root. So that's going to be our u. And then we take the derivative of sides, du is going to equal 2x dx. And here's where you kind of have the two options for how you substitute stuff in. All right, the last problem we had exactly pretty much this equation. It was 6x dx was exactly in the problem, but there's no 2x anywhere in here. So another way you can do it is you take this equation and solve it for dx, so you can just replace the dx in there. So I'm going to solve this for dx by subtracting by 2x. So now when I go in, plug this in. All right, I don't have anything that's equal to just x, so that's going to stay. X squared minus 5 is u, so it's going to turn into the square root of u. And dx is du over 2x. All right, so this other way doesn't completely get rid of all the x at the beginning, but the goal should be all the x's should cancel out in some way. And now I can see this is 1/2 the square root of u du. All right, so if you don't see exactly this equation in the thing you're trying to integrate, then you can solve for dx, plug it in, and kind of cancel things out. And then that'll kind of show you what extra terms and stuff you need. But now we can rewrite this as u to the 1/2 du. Because whenever we're working with square roots and we're trying to integrate or differentiate, we want to write it as an exponent. We're going to add 1 to the exponent. Divide by the new exponent. Dividing by 3/2 is the same as multiplying by 2/3. And those 2's are going to cancel. And don't forget to do the very last step. All right, that's not your final answer. Our final answer should be the one with the x in it. So it's going to be 1/3. X squared minus 5 is replacing the u. And plus c. That's right. There's another example of doing the substitution. You're looking for something that's inside of another function. You make that u. You differentiate that little equation to get a du and a dx so you can change your integrand. And then you take the integral or antiderivative using any of the techniques we already know, and you just plug it back in. All right, so we'll do one more example in this video. I know it's probably getting a little long, but just show a couple of different methods. So we have sine of x over cosine cubed of x. And it might be tempting, and when we're first learning u substitution, we're gonna do a lot of practice with substitution. All right, finding out what to make u is the kind of the most difficult part, but sometimes you have to try things and see what makes the problem simpler, what makes the problem harder. All right, so you might be tempted at the beginning to make u like cosine cubed of x. If you take the derivative of cosine cubed, you're gonna have to do the chain rule. The 3 goes down, you get a cosine and a sine and all that stuff. So that's actually gonna make the problem more complicated if you were to work that out all the way. All right, so for us, we're actually just gonna wanna make it cosine by itself. That way, when I take du, I get negative sine of x dx. And again, I don't see negative sign exactly there, so I'm just gonna solve for dx. All right, so now I can plug this in. Right, sine of x is on the top. Cosine is u, so if it's cosine cubed, then I have u cubed down here. And dx is going to be du over negative sine of x. And again, whenever you're doing this u substitution, if all the x's don't go away and you have x's and u's in your problem, then that's an issue, so you chose the wrong u. So here we see that the x's do go away because those signs cancel, and this simplifies down to negative 1 over u cubed du. And now that we got rid of the x's and made it simpler, now it's just kind of a much simpler thing without the trig functions, we should be able to take the integral, and the way we do that is rewriting this as a negative exponent, so that we can do the reverse power rule, add 1 to the power, divide by the new power, and plus c. All right, those two negatives are going to cancel, and my final answer is going to be u is cosine of x to the negative 2 over 2 plus c. And that's technically right, and again, WebAssign would almost certainly accept that, but chances are the negative exponent is going to move that to the bottom, so it'll be 1 over 2 cosine squared of x plus c. That's the way you would most likely see it as a multiple choice question. Again, you can see the process. At the beginning, when you're first learning u substitution, it's a little scary. You have to do a little bit of guess and check. I have the kind of intuition under my belt of knowing the correct choice for you, but you don't have that yet, so you have to do a little guess and check. Maybe you do cosine cubed at first and realize that just makes the problem more complicated. It doesn't cancel out all the x's. All right, so you try different things. Your basic goal is if you can get to an equation that has no x's in it and it's simpler than the one you started with, that's a good sign, and then you should be able to take the integral after that. All right, so those are just some examples of using u substitution to find an antiderivative.